Today we'll learn about molarity, molality and normality and what is the relation between them and how to calculate them. Now molarity. Molarity is defined as the number of moles of solute dissolved in 1 liter of solution. So molarity is the way of expressing concentration. The unit for molarity can be capital M, mole per liter and mole per decimeter cube, as liter and decimeter cube are equivalent. Now, how to calculate molarity? So this is the formula for molarity. Molarity is equals to number of moles of solute upon volume of solution in liter. Moles of solute can be defined in unit mol, and volume of solution must be in liters, not any other unit. Example: if 0.25 m solution of NaOH is given to you, so it means that 0.25 mole of NaOH is dissolved in 1 liter of solution, because molarity is moles of solute upon volume of solution. So let us solve a problem related to it. For example, a problem is given that calculate the molarity of solution having 5 gram of NaOH in 450 ml of solution. So first we will calculate the moles of NaOH. So moles of NaOH is equals to mass of NaOH upon molar mass of NaOH. Now mass of NaOH is given in question, that is 5 grams, and molar mass is 40 grams per mole. This is the molar mass of NaOH. So moles of NaOH is equals to 5 by 40, and it will come out to be 0.125 mole. Now volume of solution. Volume of solution is given as 450 ml, but we require volume in liters. So we will divide 450 by 1000 and we will get volume of solution in liters as 0.45 liter. Now as we know, molarity is equals to moles of solute upon volume of solution. So molarity is equals to 0.125 upon 0.45, and it will come out to be 0.278 capital M, or 0.278 mole per liter, or the unit can be mole per decimeter cube also. Now what is molality? Molality is also an expression for concentration. It can be defined as the number of moles of solute per kilogram of solvent. So here the difference comes that molarity was the number of moles of solute per liter of solution, but here molality is number of moles of solute per kilogram of solvent. And the units of molarity are small m. Molarity's unit was capital M, but molality's unit is small m, and also mole per kg. Now how to calculate molality? The formula for molality is moles of solute upon mass of solvent in kg. Example: 1 small m solution of KCl means 1 mole of KCl is dissolved in 1 kg of water. If it was capital M, then it would have been molarity, but small m denotes the molality. Now how to solve a problem of molality? For example, a question is given that calculate the molality of 2.5 gram of ethanoic acid in 7.5 gram of benzene. So first we will calculate the moles of ethanoic acid, that is moles of solute. How will we calculate? It is equal to mass of solute upon molar mass of solute. So what is the mass of ethanoic acid? It is 2.5 gram as given in the question. And what is the molar mass of ethanoic acid? It is 60. So moles of ethanoic acid will be 2.5 divided by 60, and that will be equals to 0.0417 mole. Now mass of benzene is the solvent. So mass of benzene must be in kg, and it is given in grams in question. So we will divide 7.5 grams by 1000 to get the mass of benzene in kg, and it will come out to be 0.0075. Now the molarity's formula was that moles of solute divided by mass of solvent in kg. So our final answer will be, after calculating, will come out to be 0.556 m or mole per kg. So this is how we calculate the molarity. It's very easy. Now which way of expressing concentration is better, molarity or molality? Molality is independent of temperature. Why? If you remember the formula, it was that molality is equals to moles of solute upon mass of solvent in kg. So it is independent of temperature, since mass is independent of temperature. But molarity is dependent on temperature. Why? Because molarity is equals to moles of solute upon volume of solution in liter, and volume is dependent on temperature. Volume changes with temperature. Thus molality is better way of expressing concentration, as it does not change with temperature change. Obviously the quantity which change with temperature is not a good way of expressing. So molality is better than molarity. Now, what is the difference between molarity and molality? So molarity is equals to moles of solute per liter of solution, while molality is moles of solution per kg of solvent. So here the difference comes. This is the volume of solution and this is the mass of solvent. The denominator part is different. Now symbol of molarity means molarity can be represented by capital M and molality is represented by small m. And the unit for molarity is mole per liter and unit for molality is mole per kg. Now molarity is affected by changes in temperature, as we have discussed, but molality is not affected by temperature change. Molarity is also affected by change in pressure, as volume is also dependent on pressure. But molality is not dependent on pressure. Why? Because mass of solvent or mass of anything does not depend on temperature or pressure. So dependence on temperature and pressure makes molarity imprecise or inaccurate. It may be imprecise or inaccurate if there is a change in temperature or pressure. But while molality will be very precise and accurate, if there is change in temperature or change in pressure also, it will remain precise and accurate. Now next is normality. What is normality? Normality is the number of equivalents of solute in 1 liter of solution. So normality is also a way of expressing concentration. It is equals to number of equivalents of solute in 1 liter of solution. So based on this, its unit can be equivalent per liter or simply capital N. The formula for calculating normality is this. Normality is equals to gram equivalent of solute upon volume of solution in liter. Now gram equivalent of solute is also equals to mass of solute in grams upon equivalent weight of solute. So if we'll put this, we'll get normality is equals to mass of solute in grams upon equivalent weight of solute into volume of solution in liters. So this is another formula. Now what is the relation between normality and molarity? This is the relation. Normality is equals to small n into molarity. Now what is this small n? Small n is the number of hydronium ions provided by the formula unit of formula unit of acid in acidic solution, or the number of hydroxide ions provided by formula unit of base in basic solution. Means in acid it is the number of replaceable hydrogen ions, and in bases it is the number of replaceable hydroxide ions. We'll see this with the help of questions. For example, we have to calculate the normality of 1m HCl. So what is the molarity of HCl? It is 1 because it is 1 and capital M denotes the molarity. Okay. Now what is N for HCl? Number of replaceable hydrogen ion will be 1 because there is one hydrogen in HCl. So 1. Now what will be normality then? Normality is equals to N into molarity. So N is 1, molarity is also 1. So 1 into 1 will be 1 normal. So normality of 1m HCl will be 1n. Now another question of normality is that calculate the normality of 1m H2SO4. So molarity of H2SO4 is given as 1m, but N for H2SO4 is 2 because there are two replaceable hydrogens. If we dissolve this acid in aqueous solution, it will give 2 hydrogen ions. So N is 2. So normality will be equals to N into M, which is equals to 2 into 1. So it will come out to be 2N. So normality of 1m H2SO4 will come out to be 2N, right? Now how to calculate the normality of 2m KOH. KOH is a base, and here the replaceable hydroxide ion is 1 as OH is 1. If you will dissolve KOH in aqueous solution, it will give only one hydroxide ion. So N for KOH is 1, molarity is given in the question as 2. So normality will be equals to N into M. It will come out to be 1 into 2, that is 2 normal. So normality of 2m KOH will be 2 normal only, as N value is 1. Now another base, if calcium hydroxide base is given and its molarity is given, so how will you calculate the normality? Here you can see there are 2 replaceable hydroxide ions. It will release 2 hydroxide ions when dissolved in aqueous solution, and so its basic solution gives 2 hydroxide ions. Therefore N value is 2. Molarity is 3. So normality can be easily calculated as N into M, that is 2 into 3, which will give 6 normal. So normality of 3m calcium hydroxide will be 6N. So in this way we can easily calculate the problem related to normality, molarity and molality. I hope you understood the topic. Thank you.